Hi, everybody. Welcome to this new episode of SageMaker Fridays. My name is Julian, and I'm a principal developer advocate focusing on AI and machine learning. Once again, please meet my co-presenter.
Hi everyone, my name is Ségolène and I'm a senior data scientist working with the AWS Machine Learning Solution Lab. My role is to help customers get their ML project on the right track in order to create business value as fast as possible.
All right, thanks again for being with us. So, where are we in this season? So we are at the second episode of our automation trip. Okay.
Automation trip.
Yeah, quite a trip. So last week we started to discuss model deployment, model monitoring, some ops concerns. And this week we are going to dive into pipelines. Okay, so the whole episode is dedicated to building an end-to-end pipeline.
Okay.
So if that's your thing, stay around. Okay, and of course we have more episodes coming in the next few weeks on automation, and then we'll dive into AutoML. And let's see what happens there. Anything can happen with AutoML. It should be fun. Okay, so Sego,
We've got some moderator.
Oh yeah, sure. If you have questions, please ask all your questions. We have colleagues, very friendly colleagues and expert colleagues who are waiting for your questions. So thanks for joining us. We appreciate it. So all your questions are welcome. Okay, so ask all the questions. Make sure you learn as much as you can.
Possible.
Okay. All right. Now we've got this covered. We can talk about the content for this week. So we're just like last week. We are revisiting an example that we covered earlier in the season. But like I said, we're going to focus on automation. So Sego, can you give us a quick recap on this use case?
Of course, Julian. So this week we are going to work on the fraud detection use case. So in episode 2 of this new season of SageMaker Friday, we train a model to figure out if an auto insurance claim is fraudulent or not. So we also analyzed a bias in the dataset and we applied mitigation techniques.
Oh yeah, that was good.
You remember this one?
If you haven't watched it,
Please.
bias mitigation techniques.
mitigation.
Very cool stuff. Episode 2.
So yes, mitigation techniques in order to build a better model. And now in this episode, we are going to focus on the automation again. And we are going to build an end-to-end pipeline that includes all the steps from episode 2. And after we are going to add the automation steps.
Okay, so pretty much everything we see here, right? So data prep, feature store, training, bias possibly, and then deploying. We'll automate all that stuff and get rid of all those complicated notebooks that we saw earlier. So that's good news, right?
Good news.
Keep it simple. So here is the notebook, or the set of notebooks we're actually going to use, right? So screenshot time. And as usual, Sego will remind me to show this before we end the episode, okay? So don't worry if you didn't catch it, okay? All right, so that's about as much slides as you will see today. And now let's jump into our example, okay? So just a quick recap, okay? In case you didn't see that episode when we prepared data, etc. What did we do here? So we actually ran through notebooks 1, 2, 3, right?
Exactly.
Where we prepared data with the SageMaker Data Wrangler, and we trained the model and we worked on bias, etc. Okay, so we're actually picking up at notebook 5. So if you're following me, that means we did not run notebook 4 because last week episode focused on deploying endpoints, model monitoring, and all that good stuff. Okay, so if you're interested specifically in that, go and watch last week's episode. Today we're going straight to full automation, but we'll discuss endpoints a little bit. So don't worry, you won't be confused. Okay, so that's where we're starting. Okay, and if you've not run this episode before, you can find lots of information in that first notebook here. And again, our goal is to automate all of it today. Okay. So maybe just a quick word about the data set. What does it look like? And what kind of model did you train?
So for this example, we are going to have two data sets. So the goal of this episode is to try to see if an insurance claim is fraudulent or not. So we need data regarding the claims and we need data regarding the customer. So
we can take a quick look.
Two data sets, one for the claims, one for the customer, and we're gonna do a binary classification with AWS in order to see if the claim is fraudulent or not.
Okay, so we have a CSV file with claims.
Describing the claims.
Okay, with all the features, and of course we have a label. Is this a fraud? Yes or no? And this has a column named policy ID, and we find this column again in the customer data set. So that's the
key,
the join column, and we see customer age, how long they've been a customer, etc., zip code, education, blah 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 blah. Okay, so simple CSV data set. Okay, there's a bit of preparation that we can do with SageMaker Data Wrangler. But as you can see here, we also have pre-processed words. So if you want to jump straight to that, you can do that. Okay. So once we've processed the data, what do we do next?
So we store our data in the SageMaker feature store.
Okay. So feature store, one feature group for claims, one feature group for customers.
For user, and after, we store the transform dataset in SageMaker feature store, and each one goes into its own feature group.
Okay. And so, of course, we're going to use this to build a data set, and we have a simple way to do this. Sego, tell us more.
Athena.
Yeah, Athena.
Athena. So yes, in order to build the final dataset, we are going to use Athena to query the offline feature store and joining both datasets with our key policy ID. And as usual, we are going to split the datasets for training and validation datasets. And finally, we will upload the files into S3.
And then we train.
Okay, so quite classical.
XGBoost, binary classification.
Data in S3 and so on.
And we'll show you the scripts. We'll show you the Python code that we actually inject in the pipeline. So you'll see how to create the data set. You'll see how to train the model. Okay, we'll look at those things again. Talk about script mode and some of those features that we covered earlier in the season. Okay, so this is as far as we went. So now let's dive into pipelining. So the purpose here is really simple. So the purpose is take every single step that we just discussed and define it as a pipeline step with inputs, outputs, and connect them all.
Exactly.
So it's like Legos, right? Once again.
And the output of one step become the
Absolutely.
input of the next step.
Yes. Have you seen the episode before? Exactly. So, and you will see it's easy to connect them. So once we have connected those pipelines, those steps as a pipeline, then we just run the pipeline. Okay. And we'll see in Studio a very nice visualization of the pipeline. We can see the executions, we can see the logs for each steps, and maybe I'll show you some failed executions just for fun. Of course. It never works for me on the first try. You should know that. I'm just pretending. Okay. And as promised last week, we'll also show you the pipeline execution for the music recommendation example. Okay, and just so you see another example. Okay, great. So let's get to work. So here we're going to work only in one notebook. It all fits in one single notebook. So high-level overview, define each step, connect them, and we'll see that we can connect them implicitly or explicitly. And then, of course, execute the pipeline and then see all kinds of things happening in Studio. Okay. All right. So let's get to work. Okay, so first we load some variables from previous notebooks. Of course, we import some objects from the SageMaker SDK, and of course all the pipelining and step objects. Okay, some technical objects that we'll need to call SageMaker APIs, potentially both or three APIs as well. Okay, lots of output path indeed, because we need S3 path to store, blast reports, training sets, artifacts. Okay, but nothing really fancy. Instance types that we're gonna use to parameterize the pipeline. We'll see in a second. We can actually set parameters. So in this case, it's mostly instance types that we want to use for the processing steps and instance counts. Okay. All right. So again, this is the whole workflow, and we're going to work on each of those steps. Okay. So first things first, pipeline parameters. Okay, because why do we need those? So you could use hard-coded values, but of course you want those pipelines to be reasonably generic. And what I mean by reasonably generic is, there is such a thing as trying to be too generic, and then it becomes nonsense because you have 500 parameters for stuff that should really be hard-coded. So be reasonable, but indeed things like instance types. Some, maybe the location of the S3 data set, that kind of stuff, is reasonable. Okay, and here we're going easy. We have just the instance type and the model approval status. Okay, we'll come back to this guy later. Okay, but just remember, we have this status and it's defined to pending manual approval. And what I'm really getting at is it's not approved. Okay. Not yet. Somebody will need to look
manually
at the model and say, yes, it's good to be deployed. Okay. So you can define parameters, and of course they can be integers, they can be floats, they can be strings. Okay. So just be reasonable, just like if you work with AWS CloudFormation for infrastructure as code, you get a good sense of, okay, what is reasonable to have as a parameter and what should really be a hard-coded value. Use your own judgment. Okay. So the first step, because we'll try to go in logical order. We could define the steps in any order, okay, and then connect them at the end. But I guess, the engineer in me thinks it's slightly more reasonable to go in order. But again, not everybody's brain works that way. I'm totally fine if you want to start with the model deployment step.
No.
Okay. Should we do it backwards? No, come on. We'll be reasonable. So first step is the data wrangler step, okay, the pre-processing step. And if you remember the past episode, how did we run this programmatically, right? Because obviously this time we are not clicking and running stuff manually in the data wrangler UI. Okay, we're running a SageMaker processing job, and we're passing to that job the actual flow, right? The actual definition of the pre-processing flow, and you can see them here, right? So there's a flow for claims processing, there's a flow for customers processing. Okay, and these are just JSON files that list all the transforms that you manually created in Data Wrangler. Okay, we looked at that stuff in detail in previous episodes. So, of course, let's upload that file to S3. Okay, fine. And let's define the input for the processing step. Okay, so as you can see here, we use this object SageMaker processing input. Okay, which is of course the flow file we just uploaded. Okay, but and maybe let me just open the file for a second. See if it opens. So this is the flow, and we see all the different steps that we created here. So what we need to do is we need to find in that flow the actual node that we want to output data from. Okay, I think it's an interesting feature where we could say, we just want, and we did this in a previous episode, we just want the output after, the first X transforms, not all transforms, okay? So that's what we're doing here. There's a bit of code here to find this node ID, which is really the name of the node in that data prep flow where we want the output, okay? So the inputs here are really, here's the flow, and here's the node output in the flow where I want to grab data, okay? So that's what we do here, okay? We find that name here. Okay? It's a little bit complicated to read here, but that's really what we're doing, okay? Okay, and so where do we store that stuff? Okay, where do we store the transform data? We store the transform data in feature store. Okay, so we do that in this feature group that is defined. Okay, so that's the first step, and then basically, okay, here's the actual step. Okay, the processor object is the compute that will just, the compute object that will just run the script, okay? And the step, okay, has a name, has compute attached to it, right? Inputs, so the flow file, and the node, and output, the feature group where we're storing that stuff, okay? So that's this one is for claims, okay? And we do the same with customers, okay? So we upload flow file to S3. We define that flow file as an input. We find the correct node. And you can absolutely open the flow files and find the node ID if you wanted. Here it's getting a little maybe too fancy for my taste. I would just hard code, or maybe I would pass it as a parameter one. Yeah, slightly too complicated for me here. And the output again is the other feature store or the feature group. Excuse me. Okay. And so obviously these have been created before. Okay. So these are not created by the pipeline. Okay, and the reason, you could create those because earlier and use them again and again because we can use versioning, right? So we can actually store multiple versions of the same features in the same feature group because we have a timestamp. Okay, so those feature groups are supposed to be pre-existing. Okay, so we have those two early steps, and yeah, maybe I can, let's see.
Not this one.
Yeah, no, sorry, not this one. Okay, so we've done those two here, right? Okay, the data prep steps. And should I zoom in just a bit? Yes, okay. All right, okay, so we've done those two here. And they're not green yet because we haven't run anything, okay? Hopefully they'll be green later. Okay, so the next step, so now we have process data for customers, process data for claims. Okay. So now we need to create the data set, okay? And creating the data set, as you explained, means running an Athena query, joining the data sets on policy ID, and saving, the training set, splitting and saving the training set and the validation set. Okay. So this is what we do here, and we do this with a Python script, okay? Because we need to run that query, etc., etc. So we're going to take a look at this script in a second. So we upload it to S3. We create our compute object, sklearn processor. Okay. Framework version for sklearn, instance requirements, some name, and that's it. And then we can create the processing step where we have, so we don't have inputs, okay, because we're passing the input data, so to speak, as command line arguments. So which Athena table to use, etc., which feature group names to use. And again, remember, these are pre-existing. And by default, when we create feature groups, we also get automatically Athena tables that we can query. Okay, so all this stuff comes from creating the feature groups earlier. Okay, which we've done in a previous notebook when we ran everything manually. Okay, so no inputs per se, but we have all the input information here. Okay, and then of course 2 outputs, the training data set and the test validation data set. Okay, right, and of course we need to pass the location of the code. Okay, and remember we said, okay, how do we connect those things? So here, and you said that was absolutely true, that the outputs of, typically the outputs of a step become the input of the next step. Okay, and I'm pretty sure we could have done it like that. You know, we could have, could probably have saved some kind of output in the previous step that we could use as some kind of input here. But as it happens, there is no input. So how do you know? Because we use the command line arguments, which is totally fine. But how do we know that this step comes after the 2 other steps? So this life-saving line of code here is what actually changes this step with the 2 previous ones. Okay, so in a nutshell, this really creates those 2 arrows here. Okay, if I didn't have this depends on parameter, then we would see those 2 steps as disconnected, and of course the workflow, maybe they would run fine, but this one would fail because it would start running, but it wouldn't find the data and blah blah blah. So of course it's nonsense. Okay, so this is how you can explicitly chain steps. Okay,
so very interesting. Yeah, this is cool.
Yeah, it's one way to do it. I think we'll see in the other steps how implicitly, when the outputs become input, you don't need to do that. Because SageMaker automatically figures out, hey, it's that thing is coming from the previous step, so it's the previous one and the next one, of course, in the right order. Let's take a look at the script really quick. Okay, so not too complicated. We grab all those command line arguments, where to find the claims feature, where to find the customers features, the name of the Athena database that has the 2 tables, and a bucket name and a prefix name to store the data sets. Okay. All right, so we grab all that stuff, build some path here. Okay. Yeah, we wait for the feature store to be ready, which is fine, because when you ingest data in the offline feature store, which really means S3, you need to wait for a few minutes for data to flow there. So in case you just created the feature group and the data hasn't correctly flowed to S3, you can wait. But in this case, data is available, but it's a good piece of code to have, right? It's one of those snippets that you want to keep around. Okay, then we create an Athena client. We have the name of all the columns.
Query.
And okay, what do we do here? Well, we select distinct rows from the claims table, joining on the customers table with the policy ID. Okay, so pretty much what you would expect.
Yeah.
Okay, and we join all the rows. So define the query string, start the query execution, get the results. Okay, and then we can just then we can just we download. So yeah, you might not know that Athena query results are saved as CSV files. Okay, so I guess we could grab this as a pandas data frame directly from the query results, which we're not doing here. Here we instead we're going for that CSV file in S3, but why not? And okay, then we load that CSV file, split 80-20 for training and test, and save that stuff to a well-known location inside the container, and SageMaker automatically copies that stuff to the S3 output path. Okay, so nothing complicated, but some good code here.
Yeah.
Some good generic code that you for feature groups and for Athena. So that's why I wanted to show it to you. You can absolutely start from there and copy paste, modify, and add that to your own projects. Okay. Okay, so now we have data set objects
Ready.
in S3.
Ready.
Okay. So the next step is to train. Okay. All right. Next step is to train. So here we're going to use our estimator friend. Again, that XGBoost object is actually the SageMaker estimator for XGBoost. Okay. So this is exactly the same code you would use in your training notebook. Okay. Hyperparameters, so binary classification, so logistic regression, an XGBoost script. We're going to take a look at this, but no surprises. Okay, where to store results, hyperparameters, infrastructure requirements, XGBoost version. I mean, the same stuff. It's really the same object, right? So you shouldn't be surprised. And then the training step is really, passing. So it's receiving the estimator and the inputs, which is really the same thing that you would pass to the fit API, right? So it's a training input with the location of the S3 training set. And hey, what do we see here? We see that we actually reuse the output from the previous step. Okay, so it's an example of what you were saying before, implicitly chaining steps because the input of this step requires the output of the other step. So unless your brain is wired backwards, you know which one comes first, right? Sometimes my brain is totally backwards. Okay, so this is how you do it, right? You grab the URI for that output from that step, and that's your input. Okay.
Cool.
All right. So now we've trained a model. So there are actually two ways to proceed with deployment. So let's say we are in we're still, even though we're automating, let's say we're still in a dev test environment. Okay. So here we can do it pretty much as we've done before. So we create a model object and we deploy from that. Okay. So that's the purpose of this step. Okay, which is really just creating the model, and you know how much I dislike the name of this API because it's not really creating a model. Training a model creates a model, right? This one should be, I don't know, register model, or I don't know what the name should be, but it's not creating anything. It's just taking that model artifact in S3 and making it available as a SageMaker model that can be deployed, right? Okay. So we're doing this. Another step, which is probably, let's go down a little lower. Oh, did I miss the register step? Yes, here it is. So another way to do this now, if we're in probably a full automation, let's say a production setting, we want the trained model to be registered in the model registry, which is a proper entity in SageMaker, and we'll look at that. Okay, so it's exactly what you think. It's all the models and their versions and their status, etc. Okay, and this is where this approval status that we set as a parameter comes in. Okay, And so when you register a model, okay, it's in the registry. We'll take a look at that. And then somebody in the ops team or can take that model, run whatever tests need to be run on it, and switch the status to approved and deploy it, right? And maybe deploy it using a Python script, maybe deploy it using a CloudFormation template. There are many ways, right? And we provide some MLOps templates. Just go and take a look at the doc, the SageMaker doc, and you'll find some templates. But these are the two routes you can follow, so to speak, right? You can do it the usual way, so train, create model, and then deploy. Or you could say, okay, train and then put the model in the model registry, and from then on, it's production stuff. I don't have permission. I shouldn't have permission. Someone will take over. Another team will take over. Make sure the model is good, and then go and deploy, possibly in a different AWS account. Okay.
That's good.
So here we're trying to do both, but I would expect, in a single workflow, we do one or the other. Okay, hope that makes sense. Okay, so let's come back here. Okay, so we created the model. Okay, and then we run bias metrics. Okay, just like we've done on in previous episodes. So here we are just running pre-training bias. So we're actually running this analysis on the data set.
On data.
Right?
And
not on the trained model.
Yeah.
We can do post-training as well. So you could argue, well, why do we do this now? We could have done this earlier. And, I think that's a fair comment. We could have done this step before training.
Training.
And we could say, well, if bias metrics are awful, then why even train? We could
Or
stop
even
there.
before create datasets. You can try to see the bias.
No, because we need to join. We need to join. Oh, we could maybe we could see some stuff already on those two CSV files. Why not? But yeah, so another way to build this would be, create data set, then clarify processor, then train, and you could say, well, check out the output for clarify. If it's awful, don't even train. But
yes.
it's just how we chain those things, that we change. The steps themselves are the same. It's just how we chain them. Okay, so here we have this, and if you've watched the previous episodes and we've discussed clarify in great detail, it's really exactly the same code, right? Create a bias config, run a bias analysis on customer gender, specifically for female drivers. Because they're actually the minority group in this data set. And there's some imbalance in the data set. So we could have a legitimate worry that as female drivers are underrepresented in the data set, there could be some potential bias on how they're predicted. As it turns out, there was a little bit.
Yeah, it was a little bit. But after
not,
with the mitigation.
And then
we
used fancy bias mitigation techniques, and then it was all great. Okay, and so we run this analysis. Okay, and the processing step. Again, we have a compute object and the actual step with the inputs. Okay, so the input is a JSON file with the metrics we want to compute. And of course, the data set, which you see once again comes from the output of the training step. So again, implicitly chaining all that stuff. And the output is the report. Okay, so we do that model registration thing. Okay. So again, sorry if I'm repeating myself. Don't confuse this with create model. Create model just, and now I can't say register, of course. Create model makes the model visible in SageMaker so that it can be deployed in the usual way, right? Creating a predictor, etc. Registering the model is more powerful because here we're actually creating a model, what we call a model package. Okay. So of course there's the model in there, but we can also pass content types, response types, instance types that are allowed to be used for deployment, whether we use endpoints or batch transform, and approval status, and we can save model metrics. So you can see it's a bigger and more interesting package than
which contains
than just, hey, here's the model in S3. Okay, so that's the difference between creating the model, which is just the model itself, and registering a model which adds the model as a package to the model registry. Okay. All right. Then we deploy the old-fashioned way. Okay, and we have we run this with a script because there isn't a deploy step in pipeline. Okay.
Good to know.
I guess the way pipeline should be used is really train, register your model in the model registry, and then use some other logic to check approval status and go deploy. Now, if you want to deploy, obviously you can. If you want to deploy, in your own account here, etc., just for testing purposes, fine. We can just run a script. Again, using a scalar processor that deploys a model. Okay, and it's a simple script. Oh, here it is. I was looking at the wrong screen here. And we pass the model name and the endpoint instance type, etc. And here we use the Boto3 API to create an endpoint config and an endpoint. Okay, so it's the low-level API, but that works too. And it creates the endpoint just like we've done previously. Okay, but again, I think this is fine for testing, but I guess the way to do this is really use the model registry. Okay, so now we've defined all those steps. Okay, and yeah, this is how it looks.
Register, deploy.
Okay, so data prep,
create,
data set creation, and then run clarify. Okay, run training. And then once we've trained, create the model the old way and deploy the model the old way.
And
okay, but that left hand branch here is, it's probably not what you want to do for full scale production. What you probably want to do is register model. Okay, and we'll see how the model registry looks in a second and what to do next. Okay, so now we have all the steps. So we just combine them, right? So the pipeline has a name, it has parameters, it has steps. And in case you're wondering, you don't need to pass them in the right order.
Oh, yeah?
Yeah, so if your brain works backwards, you can list them in any order.
Okay.
Because SageMaker will figure out where the dependencies are. Okay.
So, but it's better to put it in the good order. I guess.
But if you have parallel execution, it's gonna look weird anyway. So don't think too hard about it. Just make sure you list all the steps, make sure you list all the parameters, and you're good to go. Okay. Then we upsert, or so either insert or update the pipeline definition. Okay. And we can view it, and then we can start it. Okay.
Nice.
And then it runs for a little while.
Okay.
And we start to see blinking stuff in Studio. But okay, before we go into the blinking stuff, this is really what the pipeline looks like. And this one is kind of elaborate already. Okay. But you see the basic idea: create all those steps and chain them and run them. And generally, I would still advise that you start with either separate notebooks or that you just do it in the simple way, right? So create your SageMaker processing jobs and create your estimator. I mean, just do it the way we've been doing it forever. And once it runs and once you want to automate, start literally copying and pasting this stuff into a single notebook, because as you saw here, the syntax is extremely close. So it's really easy to move from SageMaker processing jobs to pipeline processing steps. It's easy to go from training code to training step in pipeline. It's very similar, right? So take baby steps, make it work, make it okay, and then start to automate. Don't try to do everything at once. It's too much for me. Okay.
It's good, not a good idea.
Not a good idea. So once we start, so here's the endpoint. No, this is, okay, this is what we want to see. So this is that's the graph we built. And you can see this stuff, I should show you here, right? So pipelines is where you want to go. Okay, so fraud detect, open this one. Here it is. Okay, so here's the static graph. And then you see executions.
Okay.
Okay, see, it failed the first time because I had the wrong Docker image for whatever. All right, wrong region, I think. And then it worked. Okay, and this is the execution that you see here.
Okay, so now it's green.
Okay, yeah, now it's green, and I'm very proud of it. So if you click on any step, okay, you can see all the input stuff, right? And you can see the output, obviously, the location of those data sets. You can see the log, right? So that's, in this case, it's going to be the log for the SageMaker processing script. So we see the actual query that we ran, etc., etc. And obviously for debugging is great because when one of those steps turns red, yeah, let's take a look at the red stuff here. Okay, so what happened here? Logs.
Wrong container.
Oh, it has no logs. Oh, here we are. Okay. Pool access denied for blah 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 blah. Repository does not exist. Blah blah blah. Okay, so it's me, right? It's on me. But so
it's super useful.
Yeah, it's super useful. You don't have to because there's no log because that job didn't even start, right? So I can easily see, and I think it's the same error on this one. You can easily see what went on, and you don't have to. You can do everything in Studio. You don't have to go to CloudWatch. You don't have to. Yeah. Doesn't have to be complicated. So you can see all those steps here. Right. I really like that. Cool stuff. Okay. So this execution worked just fine. What else did I want to show you? So we can also see, or I guess we'll see this in a different episode, but pipelines automatically builds lineage information. And I'm quite sure we see this stuff when we click around, but we could see the lineage for each step. So the list of input artifacts, the list of output artifacts. So you can, when you get all the way down to, hey, here's a model, you can use the UI or you can use APIs to go and find all the artifacts that came into this model. So what scripts did you use? What data set did you use? Blah, blah, blah. So lineage information, but we'll show you this in maybe the next episode, okay? And it's all built automatically by pipelines. Okay, so we get to an endpoint, but we've seen this before. It's just a normal endpoint. The interesting bit is the model registration step, okay? So if we go to model registry, we can see, and I guess this is the one. Okay, so you can see I trained 3 different versions of this model. Okay, so I can see the versions. I can see, let's click on this one.
Status.
Okay, so this one is pending manual approval. And I can see all the settings here. Okay, so I could grab this model from the package group, and I can basically deploy it in a local account. I can do anything that I want. Run some testing. Okay, I could say, okay, I'm happy with this. I'm happy with this model, and then I can go and approve it.
Good model. Best model ever. Oh my god.
Yes. All right. Update the status. And now it's approved. So whatever logic you have next, can be triggered So you could have, CloudFormation, you could have scripts that go and check that status to say, well, if a model doesn't have the approved status, then I won't deploy it. Okay. And again, I think generally this would be done in a different account, right? Because different accounts for dev and production, right?
Best practice.
Okay. So you can go, you have APIs to go and query this, of course. So again, you can build it manually, or you can use CloudFormation templates, etc., etc. We'll try and come back to the ML ops angle a little bit in future episodes, but I think we're almost out of time for now. Okay, and so in a nutshell, this is how you build workflows. You use that SDK to combine the steps, chain them, run the pipelines, track the executions, debug, find information on all the logs and on all the steps, read the logs, etc. Use the model registry to store all those different versions. And again, you can find lineage information pretty easily. You can go and approve those models and use some downstream logic to move them around and deploy them in different accounts. And I think that's it. So as promised, so this is the music recommendation example from last week. Okay, so if you watch that one, remember we had 3 data wrangler steps. Okay, to prepare tracks and user preferences and ratings. And then we combined and split this for training and validation. And then we trained. Register. And here, okay, we used I don't want to call it legacy, but yeah, the traditional way of deploying. There's even a model monitor step if you want to see this. And then of course we added it to the model registry as well. And it's probably around here. Yeah, and it's still pending. Okay. So very cool. You can do all of it in SageMaker Studio. Pretty simple. And then you can query again the model registry and decide how you want to deploy. Okay, but we'll try and come back to that very final stage in other episodes. Give you a sense of the work needed there. Okay. Well, I think that's the end. Yes. Yeah. So
we run out of time.
So here's the notebook we used. Okay, so go and grab that. And well, that's the end of this episode number 4. And next week, I'm not so sure what we're doing, but more automation.
Healthcare.
Are we doing healthcare? Okay. Oh yeah, I can take a look.
Computer vision.
We are doing. We're doing healthcare. Okay, great, fine. So let's see what happens. You never know. You never know.
We never know, exactly.
Okay, go and grab the notebook, start running stuff, and have some fun. Sego, thanks again.
Thank you, Julian.
I hope you guys learned a lot today, and we'll see you next week with more. Bye-bye.
Bye-bye.